Hello everyone, my name is Annu. I am the student of BSc Chemistry Honor second year. Today's my presentation topic is Gibbs Helmholtz equation. So as we know that Gibbs free energy is equal to H minus Ts, where G is equal to Gibbs free energy, H stands for enthalpy, T is temperature and S is entropy. So now we consider a system undergoing isothermal changes at temperature T. So for initial state G1 is equal to H1 minus Ts1, and for final state G2 is equal to H2 minus Ts2. So now we subtract the equation second from first, means final state from initial state. Then G2 minus G1 is equal to H2 minus Ts2 minus H1 minus Ts1. Then G2 minus G1 stand for del S, which means free energy change, and H2 minus H1 stand for del H, which means enthalpy change, and del S stands for entropy change. So as we know that H is equal to U plus PV, and then put this in equation A. So G is equal to U plus PV minus Ts, and by differentiating this, dz is equal to du plus p dv plus v dp minus t ds minus s dt. As we know that the entropy is equal to q by t, where q is amount of energy absorbed. So TdS is equal to Q, and also we know that from first law of thermodynamics, Q is equal to du plus pdv. So TdS is equal to du plus pdv. Put value of TdS in equation third. So by cancelling TdS by TdS, left dz is equal to v dp minus s dt. And now taken at constant pressure, dp is equal to 0, so dz is equal to minus s dt. dz by dt is equal to minus s at constant टेम्परेचर. इसको भी हम इनिशियल और फाइनल स्टेट में लिख सकते हैं. सो dz1 by dt is equal to minus s1 for initial state, and dz2 minus by dt is equal to minus s2 for final state. By subtracting equation 6th from 5th, so we see that dz2 minus g1 by del t is equal to del s. So g2 minus g1 we can written del g. So del g by del t is equal to minus s. Put this equation in equation 4th, and which is this. So del g is equal to del h plus t into del g by del t at constant pressure, and this is the Gibbs Helmholtz equation. Thank you. This is my today's presentation.